All right, guys, so we are going through the review for quiz 2 on similarity. Hopefully some of this stuff comes pretty easy, and then some of these, again, this is a good review, so you might want to watch it a few times. Again, I would try the review first and then come back to the video once you've tried it, maybe circling ones that you don't know. If you just watch me do it and fill in the answers, you're really not studying. So I wouldn't be surprised if you didn't do well on the quiz. So once again, this is time where you could, if you already started watching the video, you could hit pause, you could try it, and then you could come back and watch the video to kind of check your answers, right? That's the idea here. Okay. All right, so let's jump in. What are the 3 ways to prove triangles similar? The first one is if they have 2 angles the same. So angle similarity, and that is a postulate. Yes, you need to say postulate. We also have side angle side. So if the 2 sides are proportional and the angle between them is congruent, we can use side angle side similarity. That's a theorem. And last but not least, if all 3 sides are proportional, then it is SSS similarity theorem as well. So only postulates AA. Okay, so the first section, I simply just asked you to tell me if they were similar or not, and if so, by which one. So I didn't have you naming anything or using any letters yet. So this part's a little easier. So let's see how you did here. Okay, so on this first guy, first things first, I notice I have vertical angles that I can mark congruent, so I absolutely should. I also have some random sides here, but one side is never enough. Like you have to have 2 here and 3 here. So these sides are really just distracting information. But what I do have is another pair of right angles. So I have angle in both of them. So these 2 would be similar. Yes. And that would be by AA, similarity postulate. Okay. In B, the 2 triangles I'm looking at are this triangle and the big triangle. And the thing is, they actually do share an angle because they overlap that shared angle right there. The problem is, that's it. I would have to know these lines are parallel to be able to use the one we used all day, and I don't. So unfortunately, one angle that they both have in common is not enough. So this would be a no. Okay, C. C is that one that we were just talking about. They both have this little angle here that's an overlapped angle or a shared angle. And then because of the parallel lines, they have these congruent corresponding angles. Those 2 are congruent. These 2 are congruent. All 3 are. But remember, the little triangle has those 2, and the big triangle has that one and that one. So this is AA. So when you have this parallel line scenario where you have one of the sides of the triangle and then you have this parallel line through it, it's always AA. So that's easy to remember. Okay, D is a bow tie scenario. The outsides are not parallel, so I'm not going to be able to use my alternate interior angles, but I can add my vertical angles. So as soon as I add vertical angles, I have 2 sides and an angle. So the only one that I could use is SAS, and I just want to make sure that it does go SAS, and it does. So then the angles are good. Now I just have to check the sides. So let's match them up. 4.5 is the bigger of this set, so it's going to go with the bigger one over here, 8. And I'm going to check that with 2.5 and its corresponding side, 5. So unfortunately, these do not reduce to the same values. This reduces to 1/2. And let's see, I can give you exactly what that reduces to. Yeah, so this is like 0.5 and this is like 0.5625. So these are not equal. So unfortunately, even though it looked like it was going to work by SAS, because the sides didn't have the same proportion, these are not similar. So be careful. Just because you have SAS or just because you have SSS doesn't mean it always does come out. You actually have to check the proportions. All right, so E is another one of those bow tie problems. Obviously, we have the vertical angles. Those are always the first thing I mark. Because the outer lines are parallel in the bow tie problem, you do get to say the alternate interior angles are congruent. So like those 2 are congruent, so are those 2, but that's overkill at that point because we only need 2 angles. So I can use angle similarity postulate. Again, the fact that they were parallel is what allowed me to use that Z pattern to say that those alternate interior angles were congruent. All right, in F, let's see. In F, I have side angle side and side angle side, so I'm going to go with that. Obviously, the angles are congruent, so those are good to go. Now I'm going to match up 8, which is the smaller one over here, with the smaller one over here too. And I'm going to match up 14 and 3.5, and I'm going to see if this is true. Well, 8 divided by 2 is obviously 4, and 14 divided by 3.5 is also 4. So these are proportional. So that means they are similar by SAS, similarity theorem. All right, and last but not least, in G, they gave you all 3 sides, so you can pretty much guess we're going to be checking for side, side, side. which means I have to check all three sides. So I'll start with 14. 14 is the smallest side here, so I'm going to match it up with the smallest side, 11. 18 is my medium side, so I'm going to match it up with the medium side here, 14.4. And 20 is my biggest, and I'm going to match that up with the biggest over here, 16. So I need to see if these all come out to the same thing. So I'm literally just plugging these guys into my calculator. And seeing what I get. So these two guys both come out to 1.25, but this one comes out like to 1.27 repeating. So unfortunately, that guy means it fails. So these are not similar. Almost, but that one failed. So not similar. We tried SSS, but it didn't work. Okay. So then I kicked it up a level because on the next slide, in the next question, I asked you not only are they similar, and if so, tell me which postulated theorem, but I want you to write the statement starting with triangle ABC is similar to blank. So you actually have to write the statement as well if you think they're similar. So let's see. So a lot of these might be similar to ones you're seeing, no pun intended, from the question number 2, but now we just have to name the actual similar triangles. Okay, so, this one looks familiar. It's that bow tie problem. I know I can immediately put in the vertical angles, and because these outer lines are parallel of the bow tie, I know that my alternate interiors are congruent. So those two are congruent, so are A and G, but again, 2 angles is enough. So yes, they're similar. I'm going to go to the Y, AA, postulate, similarity postulate. So then I have to say the statement. Now you need the whole statement, which is ABC is similar to, and I said you need to do it in that order. Some of you try to get creative and use your own version. If I say triangle ABC, you have to use that. So let's see, A to B to C. A to B to C goes across the parallel line to that angle and then to the vertical. So that would be GRC. Okay. If this was a quiz, I'd probably give you like 2.5 points. 1/2 point for saying yes or no, and then a point for your statement and a point for the why. All right, let's look at B. In B, the first thing I notice is a kind of a bow tie situation again. I should throw in the vertical angles. And I have 2 sides in an angle, and it does go SAS. So I'm going to try for SAS. That's the plan. So the angles are good to go, but the sides, I have to check the proportions. So 15 is the smaller one of these two in this triangle, so I have to put it with the smaller one, which is actually 10. So careful, it wasn't 12. A lot of people mess that up. And then 18 would go with the bigger side, because it's the bigger of these two, 12. Okay. So let's see. 15 divided by 10 is 1.5, and 18 divided by 12 is also 1.5. So this one checks out. So I know it's SAS. I can circle yes. I know it's SAS congruency theorem, and then I just have to name them. So this one is ABC. This goes across the non-marked side and then across the larger of the 2 sides. So non-marked, larger. So over here, I didn't put a letter here. Uh-oh. Let's put a letter in there. Let's call this TR. Okay. So across the non-marked and then across the larger would be TRC. Sorry about that. So triangle ABC is similar to TRC. Careful. This messes people up because people always think that this guy has to go with this one. Not necessarily. It has to match size. So again, 15 was smaller, so it had to go with the smaller one over here, which was 10. So be careful. If I was setting angles equal, like these 2 angles, B and R, would end up being the ones that are equal to each other, not B and T. This is not an alternate interior scenario. So you got to pay really close attention to the things that match up. And if you get confused, don't forget, you can use once your statement is correct, you can use it like, angle B goes with angle R. Side BE matches up with RC, Okay. We have a couple more of these. This is a good one. So in this one, I don't have anybody's parallel, but I have this guy's 105 and this one's 75. So I have a linear pair here. So if this is 105, then this has to add up to 180. So this actually does end up being 75, which means these 2 angles are congruent. And then, hopefully you guys noticed, there's a shared angle. That little guy right here is a shared angle. It's in both. It's in the little one and the big one. When you see this scenario, we typically do use that shared angle. So if they have the shared angle B in common, and then they have both the 75, then they have AA similarity. Okay, so I know it's AA, and it's postulate. And the statement would be A to B to C. Triangle ABC is similar to QBG. Triangle QBG. Again, I need this whole statement, just not the final part here. Okay. And then, oh, and yes. All right. And then in D, I got a bow tie situation, so I can do the verticals. And then let's see, I have two sides over here, and I have two sides over here. And so if I was trying to do SAS, I might say 40 goes with the 20 because it's the biggest, 18 goes with the 9. And here's the thing, these both reduce to 2, but this is not similar. Why not? The proportions work, they had the vertical angles. Because even though it had two sides and an angle, it doesn't go side, angle, side. See, this angle is not between the two sides. It would have to be that guy there. So this is not congruent, even though you had two sides and they were all proportional. So you really got to watch the order. Remember, side, angle, side is when you have the two sides and then the angle you're working with is perfectly where the two sides meet. And that was not the case here. So we cannot use side, angle, side. Okay. So now we're going to get into some solving with similar triangles. Okay, so first we're going to confirm that the triangles are similar. So they gave us angle W is equal to angle U. And then this is kind of a bow tie, so we know these two angles are congruent. So they're definitely similar. But this did help me tell how they were similar. Like those two angles go together, these two go together, which means those two also go together. So that helped me decide like which sides should map. If it helps you, you could write a statement. So you could say triangle WRL. You don't have to do this. WRL should match up with UPL. It's kind of nice because then you can see exactly who should match, you know. But that's up to you. Okay, so then they want a scale factor. Now, I didn't say which triangle to which, so you can do it in any order. So we just need two sides that match. So once again, I get people who try to put 24 with 10. But in this triangle, this side actually would match with LP, right? WL would match with, I'm sorry, LU. This side would match with LU. So those two go together. So that means I can't use 24 and 10. The two that actually correspond are these two. See those two there? So my scale factor is going to be 15 to 10, which reduces by 5 on top and bottom, so 3/2. Or I would have accepted 2/3 because you could have went the other direction. Okay, so now we need to solve for some stuff. First of all, if I want to start with x, x is actually an angle. And so remember, the angles that correspond are equal. So like I already know this one's 33 because I know they're vertical. So I could add these two guys together and find out what w is because that should all add up to 180. And so I end up with this, and 25 is the missing angle. And then remember, w is corresponding to u, so those two things are equal. So that means that this angle also has to be 25. So then x just ends up being 5. Okay, the measure of angle W we just said was 25, so we're good to go there. All right, now let's start solving for some sides. We're going to set up some proportions. So I need LU. If you want to put a variable in here for the meantime, don't use x because we already used x, but if you want to put a new variable to help you, put a new variable. So I can call it y. So we're going to go back to our original relationship, which is I know that 15 went with 10, so I can do 15 over 10 equals, and I'm going to have to use 24 and y, and I'm going to have the 24 on top because I had the 15 on top. Now, if you want to reduce this to begin with to 3/2, it will make the numbers nicer, but you can solve it either way. So I'll show you that. If I didn't reduce it, I would have 15y equals 240, and then I would divide both sides by 15. And 240 divided by 15 ends up being 16. Now, if I reduced it first, I would get 3y equals 48. Guess what that is? Still 16. So it doesn't matter if you reduce it or not. Either way, we're going to get out LU, which was the one we called Y, as 16. All right, last but not least, we want WR, which again, you could put a variable in there. So I don't know, I guess I'll call it W. So I'm going to go back to my scale factor of 15 to 10, or you can use 3/2. It is easier to use the 3/2. So that would be my suggestion, but some people just immediately go back to that side. So 15 is to 10, as since W is in the left triangle, it would be W over its corresponding side, which is 16. Again, I would reduce it to 3/2. You don't have to. It just makes the math easier. So I get 48 equals 2W, so W equals 24 as well. So that was kind of interesting. That means these two sides ended up being equal, which I didn't mean for that to happen, but it did. We're going to go with it. Okay. All right. Okay, and this next one can be a little tricky. So you have two ways that you can solve this. We learned a couple of different tricks to solving this, but there is one part that people typically mess up. Okay, so first of all, these two lines are parallel, and if these are parallel, we know that these two triangles, the little guy and the big guy, are immediately similar by AA. So that was easy. Now we need to solve for this missing stuff. So the first thing I would do is I noticed that this whole side PS is 28, and then they gave me that little portion is 8, so that means I can fill in this. So immediately if I do 28 minus 8, I get this little portion, which is 20. Okay. So we learned that if you have these parallel lines, you have this parallel line to this side, that it cuts these two sides proportionally. So if I do 2 to 8, then that's the same as the way this side gets cut. Or I'm sorry, this was a 20. 20 to 8, that's the same as this side gets cut, which is 16 to, I guess I could throw a little x in, 16 to x. You guys see that? So I made HDX because it didn't have a variable. Okay, so then I could cross multiply and solve. So again, this is the one where you can do like top over bottom equals top over bottom, right? Because of the parallel lines. So then we have 20x equals 16 times 8, and I get 128, and then I divide both sides by 20, and I get 6.4. So x is 6.4. So that was one of the things they asked for. HD is 6.4. They also asked for PB, but we already got that. PB had to be 20 because it was the part that was left over. Now, this is the part that messes people up. They want DS. DS is this side. This side does not get cut by the parallel line. So you can't just do like 20 over 8 equals 18 over this, which I guess I'll use y for that bottom. So once again, you cannot say 20 is to 8, which is like part over part, equals 18 over y. That's not true. 18 and y are not pieces. They are small triangle, big triangle. You cannot do that. Do not do that. So if we want to solve for the lengths that are actually the parallel lines themselves, 18 to y, you have to go back to little triangle over big triangle side. So what's one of the sides in the little triangle? We know more, but I probably would use 20 since I know the whole thing. So 20 is one of the little sides. And then what's the big side that matches with 20? The big side that goes with 20 is the whole thing, 28. So again, I can't just use 20 over 8 because 18 and y is a little side and a big side. So when you're using the parallel ones, you have to actually use the little triangle and the big triangle. Okay, so then I can cross multiply. I'm getting some big numbers here. 504 equals 20y. Divide both sides by 20, and so I get y equals 25.2. Okay, so that is the most commonly missed one. All right, let's look at the angles. They want PHB. PHB is this angle right here. Well, if the lines are parallel, these are corresponding angles, which means they're equal. So that is also 75. It's also because the two triangles are similar. So this little position is the same as that. And then angle P, well, if this is 75 now, and that's 38, we can add 75 and 38 and take that away from 180, and that makes this missing angle 67. Again, watch this as many times as you need to get comfortable with the problem. Okay, then we moved on to proportionality theorems. We did this towards the end of class. So the first one was, once again, and we kind of just did this. Once again, if you have two parallel lines, then the parallel line in the middle cuts this proportion, x plus 7 over 3, into the same ratio as the other side. So I can do top over, you can basically set up a fraction over that parallel line. So this over this equals that over that. And so then I can cross multiply. Again, one of the most common mistakes that I get here is people don't distribute the 4 correctly. They say 4x plus 7, but don't forget you have to multiply the 4 by the 7. So 28. So then I get 4x equals 16, so x ends up being 4. Okay. And in B, let's see, in B they're parallel, so again they get split. I have these two, but I need these two to be able to work with this. Well, the good news is, if this is 9 and the whole thing's 15, I can just subtract to get that that's 6. So I can do 6's to 9 as go in the same direction. X minus 6 is to 12. And then I can cross multiply. So I'm going to add the 54. I'm going to divide both sides by the 9. And I get 14. If I then asked you to solve for DH, because I do, then you actually have to plug 14 back in. So then I would get x equals, x is 14, and then DH equals 14 minus 6, which is 8. So just make sure that you answer the full question on the quiz. Oops, it went backwards. Okay, then we also did some proportionality, but if it was 3 parallel lines, it's the same thing. If it's 3 parallel lines, you're setting those two as a ratio and those two as a ratio. So 2x minus 3 over its bottom part, 5, equals x plus 1 over its bottom part. Once again, you have to show all this work on the quiz, so make sure you're showing me all your work on the review. Okay, so then I subtract 5 and I get 9x, I add 21, I get 26, and this one doesn't come out nice, it just stays 26/9. That's the best we can do. If you tried to write it as a decimal, which you can, it comes out to 2.8 repeating, so you just have to have a repeating symbol. All right, D. Now D is an interesting one because here's the problem. I know in D that I can do 4 over 12. The problem is I don't have either part of this, and I would at least need one of the parts, right? So this is the one where we said if you know the whole thing is 18, and I think, shoot, I don't think I told you what to solve for, so I'm going to go ahead and put it in here. I want you to solve for, I forgot to say, I want you to solve for, let's go with FG. Okay, so so anyway, if the whole thing is 18 from here to here, and I want you to solve for FG, and you don't have either part, this is where I said, let the one you want to solve for be X. So I'm going to put a little X here. And then I said this side would always be the whole thing minus X. So this part is going to be 18 minus X, always. If this was 20, this part would be 20 minus X. One side is always X, and the other one is always the whole thing minus X. So then let's finish our proportion. 4 is to 12 as X is to 18 minus X. So then I would distribute properly, right? Be careful. So 4 times 18 is 72 minus 4x equals 12x. Add the 4 to both sides, 4x, excuse me. Divide 72 by 16, and I get 4.5, or 9 halves if you wanted to leave it a fraction. And the nice thing is, because you made x FG, you solved already for exactly what you wanted, right? X was FG. Okay, make sure you take a look at that because that does get people. Okay, proportionality with angle bisectors. So we also learned about when you have an angle bisector that this little ray splits it into the same proportion. So these two are the same as the ratio of those two. So I'm going to do 24 and 36. The outer two sides are the same ratio as the way this gets split up. Some of you in class were doing like 24 over that part equals 36 over that part. That actually will give you the same thing, because that's a property of proportions would say that they're equal. So you could solve it either way. But I tend to do the outer two sides and then the side that gets split up. Okay, so again, you could reduce this first, but if you don't, then we end up with, let's see, 384 and 26 times W plus 3. So 78 and 384, and then I would take 384 minus 78, and I get 306 equals 26W. Divide both sides by 26, and we get a really nasty number, so I'm going to reduce the fraction 306 over 26, and it reduces to 153 over 13. Yuck, but it's the best I can do because the decimal doesn't repeat, so there's no other way for me to write it. Okay, in this guy, same thing. We have this angle that bisects and splits this side. So I would normally be able to put this over this. The problem is I don't have any expressions for either part. So again, they want me to solve for SB. Let that be X, and let the other side be 24 minus X, the whole thing minus X. So then I can do 24 minus X over X equals 48 over 28. 672 minus 28x, I would add 28 to both sides. So I get 76 equals 672. Divide both sides by 76. Again, we get a nasty number, but that fraction does reduce to 168 over 19. You can't, I don't want to round a decimal. It needs to be perfect. So again, this is what I got when I reduced 672 over 76. So those are some nasty fractions, but you know, be prepared. You might see some nasty fractions. You should know how to reduce them properly. All right, and last but not least, I gave you one more that is the commonly missed one, and that's the one where I give you the parallel lines, but I also ask you to solve for the lengths of stuff that are parallel. So again, X is the easy part, because if these are parallel, then you can do this part over that part, so 9 is to 12, as this is to this. That one's easy, no problem. Cross multiply. And so we get X equals 12. Not a problem. Easy peasy. It's the Y. Remember, when you're dealing with the sides, we just did this earlier in the video. When you're dealing with the actual ones that are parallel, Y to 25, you have to use a little triangle side over a big triangle side. So like if you want to use 9, which is a little triangle side, you can't use 12. You have to use the whole big triangle side, which is 21. So be careful. Then you can solve. So then I have 21y equals 225. Yeah, 225. I divide both sides by 21. I doubt this comes out nice. Nope. So 225 over 21 reduces to 75 over 7. Again, sometimes I'll make them come out nice, like the answer might just be 3, and sometimes you're going to get a weird fraction. That's okay. What I don't want to see is the decimal like this. Like this decimal is like something like this and it keeps going on. I don't want you guys to just say, oh, 10.7. No, that's not good enough. That's you rounding. I want the perfect exact number, which means you just have to simplify the fraction. Again, sometimes they make them nice, sometimes they're not so nice. So I would be prepared to see both. Okay. All right, that is everything. Again, I would maybe take a look at this tomorrow morning before the quiz, because we are going to do the quiz first thing. If you need extra help or you want to go through any of these questions, come in tomorrow at 9:15. I will be available and can answer any questions. I'll start the Zoom early. I usually start at 9:15. So feel free to come early if you have any questions. We'll go through it. Otherwise, look through these problems and make sure you're comfortable with how to do that, and you really should be fine for tomorrow. Okay, have a good night.